All right. Good morning, everyone. Today we are going to start a new unit on exploring similar figures. So today we're going to be exploring similar polygons. Similar figures is defined by similar figures are figures that are the same shape but different sizes. A symbol to say that something is similar is this little squiggly. The definition of similar triangles is two polygons are similar if and only if their corresponding sides are proportional and the measures of their corresponding angles are congruent. So in case you have a little trouble remembering how to set up proportions, I am going to attach a video to this post to help with that if you're getting a little confused at home, but we will review it tomorrow as well. So looking at this first picture, they're asking us, is polygon WXYZ similar to polygon PQRS? If so, write a similarity statement. So are all corresponding angles congruent? That's the first thing you need to know to find out if something is similar. So this angle is congruent to this one. This angle is congruent to this one. This angle is congruent to this one, and this angle is congruent to this one. We know that by those tick marks. So are all the corresponding angles congruent? Yes, they are. Are all the corresponding sides proportional? These are the two questions that you need to ask yourself in order to define similarity. The corresponding angle should be congruent and the corresponding side should be proportional. But we have to do a little bit of work to find out if we have proportional sides. To find out, we have to set up ratios of corresponding sides and simplify. All ratios should be equivalent if the polygons are similar. Okay, so for example, if I set up a ratio here, I usually, when I'm going across, I put the two things that are similar next to each other. So this side is similar to this side because the angles that appear on that side are the same. So these two sides should be similar. Okay, because both figures are upright and the figures we're assuming are similar. So I'm going to put a 12 on my numerator and an 8 next to it on my numerator. So this fraction is going to represent polygon WXYZ. This fraction is going to represent polygon PQRS. Next to each other are the things that are similar. So up and down, we're representing one polygon. Sideways, I'm representing similarity between the two figures, just to kind of help you memorize what should go where in that proportion. So I can just pick any other sides that I think are proportionate or similar, I guess I should say. So over here, I could pick the 9, and over here, I could pick the 6. So the 9, I'm going to put here because the 9 is in the triangle with the 12. So I'm putting it underneath it. Next to the 9, I should be putting what I think is similar to it. I think 6 is similar to it. So the key thing to make sure you're not messing up your proportion here is the 6 and 8 are in the same triangle, so they're on the same fraction. 12 and 9 are in the same polygon, so they're in the same fraction. Sideways, 12 was similar to 8, 9 was similar to 6. So now all I'm going to do here is reduce these fractions, or you could throw them right into a calculator. So it's really whatever works for you. If I reduce to this fraction, 12 over 9, I ask myself what number goes into both of those. 3 goes into both of those. So if I divide 12 by 3, I get 4. And 9 by 3, I get 3. This one, what's the largest number that goes into these? A 2. If I divide 8 by 2, I get 4. 6 by 2, I get 3. 4 over 3 is equal to 4 over 3. So I know that these are proportionate sides. I know that because when I set up my ratios were equivalent. The other way you could have done this, take out your handy dandy calculator, could have done 12 divided by 9 and got 1.33. 8 divided by 6 got 1.33, and notice they were the same. If they are the same, then they are proportionate sides. Okay, in this one, are these triangles similar? If so, we're going to write another similarity statement. I just want to make sure I'm still recording here. Okay, good to go. So in this picture, are they similar? The first thing to figure out if they're similar, these two questions. Do I have corresponding angles that are congruent? So I have this angle marked with 2 tick marks, this one marked with 2 tick marks, this with 1 and this with 1, the other one unmarked. So I would say yes, those corresponding angles are congruent. If I just turned this triangle, it would look exactly like the other one, just a little larger. So remember that triangles are not always going to be in the exact form you want them to be. You can turn them, twist them. So now I want to think about similar sides. If I'm going to call a side similar, so let's just say I want to set up a proportion now to see if my sides are proportional. So I want to use 12. So in order for me, since this triangle's turned, in order for me to figure out which side should be proportional to 12, okay, I want to look at what angle it's across from. So it's across from 2 arcs. So in this triangle, I'm looking for the side across from 2 arcs. That's 18. So that should be next to it. Remember, under the 12, I should be putting another side that's in this triangle, the same triangle. So let's pick another side here. Let's do 16. So if I choose 16, I'm going to put it here. 16 is across from the not labeled angle. So in this triangle, I'm looking for the side across from the not labeled angle, which would be 24. Okay, now I'm going to think what I can divide these by, or I can put it in my calculator. If I wanted to divide them, I could divide these by 4. 12 divided by 4 gives me 3. 4 divided by 4 gives me 4. I could divide these by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. So I've already seen that these are proportionate using my simplifying. But I could also do 12 divided by 16 to get 0.75, 18 divided by 24 to get 0.75. So now that I've proved that the corresponding angles are congruent and the sides are proportional, I'm going to say yes, they are similar. And then it asks me to write a similarity statement. So when you're writing a similarity statement, it's just kind of like our congruency statements that we wrote a while back. So you would say triangle ABC is similar, instead of a congruent sign, it's similar to triangle. Now you want to put the angles that match up. So A has 1 arc, U has an arc in the other one, so U should come next. 2 arcs on the B, so the next one should be V. And then lastly, I have T. So that is our congruent statement. Similarity statement. All right. Flip that page over. You get a little crazy. So now we're given that 2 figures are similar. They're telling us they're similar. So now we're going to beef it up a little bit. Instead of trying to figure out are they similar or not, now we're going to be trying to find different sides or variables using our proportions. So when we set up a proportion, we're just looking for what sides would be similar. So if I want to find x, I'm going to use these 2 sides. They're clearly similar. Okay, they're both between the 1 arc and the 2 arc on each triangle. So I can put those next to each other in a proportion. Now, this is the part where you have to pay attention. I could not choose these 2 to put in. Okay, I can't choose to put these 2 in this, or I'll have 2 variables, an x and a y. And if I have an x and a y, I can't solve it for anything here. So I want to choose these 2 sides that are similar because they're both numbers. I would put the 32 under the x because they're in the same triangle. The 16 under the 13 because they're in the same triangle. Okay. Now, I have to choose those 2 sides because they're numbers. Now I only have 1 variable in this equation. Now, hopefully you remember this from middle school. You're going to cross multiply here. So you would do 16 times x equals 13 times 32. Okay? So 13 times 32 is going to give me 416. I'm going to do it down here. And that is equal to that 16x. Now I would just divide by 16 on both sides, and I would get that x is 26. Okay? I'm not done here. They asked me to find x and y. So I still have to set up a proportion to find y. Now I can use that same thing I used over here. I can still have that 32 and 16 down here. Okay? But now on the top, I want to deal with y. So y is in the triangle with 16, so I'm going to put it on top of the 16. And then the similar to y was 38. So I'm going to put that here. And 38 is in the triangle with 32, so it should be in that fraction with it. Now I'm going to cross multiply again. 38 times 16 is going to give me 608, and 32 times y gives me 32y. And then I'm going to divide by 32 on both sides, and I get that y is 19. Okay? Okay, let's do two more together here. Given that the two figures are similar, find the value of x. So they're telling us they're similar. X would have to be similar to, if I tilted this, it would be similar to 9. X is across from that one arc, and so is 9. So I'm going to put those next to each other in a proportion. And then on the denominator of the proportion, I'm going to choose two similar sides. Now, if I tried to choose 10, that's not going to work because the side similar to 10 would be this one in the other figure, and it's not labeled. So I have to use this 8. The 8 should go under the x, okay, because they're in the same triangle. What's similar to the 8? It should be across from the two arcs. Across from the two arcs here is 12. Now I'm going to cross multiply to solve. 9 times 8 gives me 72. 12 times x is 12x. I'm going to divide on both sides, and I get that x is 6. One more of these guys. This one's going to give us an expression this time. So I want to solve for x, so I definitely need to use this x plus 1 on one of my fractions. They look like they're actually both right side up this time, so x plus 1 would be equal to, similar to 24. They're both between that one arc and two arc, so I'm going to put 24 next to it. And I can't use 18 up here because I don't have the other digit here. So I'm going to have to use my 12 and 18. 12 should be in the fraction with x plus 1 because they're in the same triangle, and the 18 should be here. This is right here where you really need to pay attention. When we cross multiply here, that 18 is multiplying by x plus 1, so we have to distribute. So make sure that x plus 1 gets put in parentheses. And then I have 24 times 12. 24 times 12 is going to give me 288, and I'm going to distribute this 18 to get 18x plus 18. If I take away 18 from both sides, I'm going to get 18x equals 270, and that would make my x equal to 15. Another important term in this section is scale factor, which is a ratio of corresponding sides of similar figures. In easier terms, it's what you multiply the smaller triangle by to equal the larger triangle, or vice versa. Because you can have a scale factor that takes you from big to small or small to big. So what you multiply the smaller triangle by to equal the larger triangle, or vice versa. So if I'm looking at this picture and they tell me that ABC is similar to HGF, find the scale factor. I'm trying to find two sides that are similar and see what I would multiply one by to get to the other. Okay. There are two ways to find scale factor. A lot of times, guys, I am asking you for a scale factor and I'll say from one to the other. So you'll notice right here it says from ABC to HGF. So it's saying from this one to this one. So they're asking you, how do you go from this to this? Okay. If they say from EG, so this one you're going from big to small. This one, EFGH to ABCD, if you're going to small to big. Okay, something you need to know about scale factor is if your scale factor is greater than 1, then the object is, or polygon is, getting bigger. If it's less than 1, but not, like, it's never going to be a negative number. So if it's like a half, then you're reducing in size. So it's getting smaller. So if your scale factor is greater than 1, we're enlarging the polygon. Less than 1, we are reducing it. That's important. So like this question's asking you, how do you get from the big one to the small one? So we want to have a scale factor that's less than 1. Here they're asking us, how do you get from the small one to the big one? So we want a greater than 1 scale factor. Okay. So in order to do this, I would just pick two sides that are the same or similar, sorry. These look like right angles, so across from them, I would say that those are probably similar sides. I also know that B is in the same order in the similarity statement as G, so they have to be the two congruent angles. So across from them, I should have similar sides. So 84 is similar to 14. If I do 14 divided by 84, I'm going to find the scale factor, okay? Because I'm doing the bigger number divided by the smaller number. Okay, if I did the bigger one over the smaller one, I would get a larger number. So in my calculator, I'm going to do 14 divided by 84, and I get 0.166. Could I reduce this so that I don't have a decimal? Because Miss Sweeney would really like it if your scale factors were in fractions. So is there a number that goes into both of these? So I definitely could divide both of them by 2, right? So then this would be 7. And 84 divided by 2 would be 42. Can I reduce that further? It looks like 7 goes into both of those. So if I divide this by 7 and this by 7, I get 1 over 6. Okay, so my scale factor here is 1/6. My scale factor is 1/6 if I want to go from the big triangle to the small triangle. What that means is if I multiply any of these similar sides by 1/6, I would get that smaller side. So when you multiply by 1/6, it's the same thing as dividing by 6. So if I look at 72, the side similar to 72 should be 12. If I do 72 divided by 6, I get 12. If I do 48 divided by 6, or multiplied by a sixth, I get 8, which is that similar side. Okay. If I was going backwards, if I was going small to big, I could multiply by the reciprocal. So I could do times 6. So if I did 14 times 6, I would get 84, which is its similar side. Let's try one more of those. Now we're going from small to big. So now we want a scale factor that's larger than 1. So in this one, I have 7 and 14. So this one should be pretty easy. You can kind of ask yourself 7 times what, or 7 times x equals 14. That one should be pretty easy for you. If you divide 7 on both sides, you get 2. If you didn't know that off the top of your head, you can also do 14 divided by 7 to get 2, which is your scale factor. So if I do 7 times 2, I get 14. If I do 13 times 2, I get 26. If I do 6 times 2, I get 12. So pretty easy here. What times 2 would give me 13? Vice versa, I could do 13 divided by 2 to get that my x is 6.5. Okay, so sometimes we can find our missing x or y just by using the scale factor. Sometimes we don't even need to set up that proportion. Okay, just make sure I'm still recording good and dandy. All right, let's finish up here. Last one. If two polygons are similar, then their perimeters are also proportional to the scale factor between them. So for example, if I'm looking at this picture and they say these two polygons are similar and they want me to find the scale factor, okay? First of all, I got to label. These two sides are congruent because these are rectangles, so this is 14. And then these two sides are congruent because it's a rectangle. And same with these two. So now I have quite a few things labeled. The only thing that I'm missing is these two sides, which they should be the same. So I'm just going to call them x and x. I have the perimeter of this shape because I have all four sides. So 20 and 20 gives me 40, plus 14 gives me 54, plus another 14 gives me 68. So the perimeter of this shape is 68. This one I have 50 between these two sides, but I got to find these two sides. What I can do is figure out what would I need to multiply 20 by to get to 25. I can do that using my scale factor. So if I do 25 divided by 20, because these should be similar sides, I'll get my scale factor. So if I reduce those, I can divide both of these by 5. That gives me 5 over 4. So if I multiply 14 times 5 over 4, so I'm doing this side times my scale factor. So 5 over 4 equals my scale factor. If I multiply this side by 5/4, which is my scale factor, I just put 14 over 1 to make this easy to multiply. Okay. 14 times 5 is going to give me 70 over 4, which gives me 17.5. So that means this x is 17.5. So the perimeter of this polygon, if that side's 17.5, this one should also be 17.5. So I'm just going to add in my calculator 17.5 plus 17.5 plus 50, which is those other two sides. So I'm adding all four sides, and I get the perimeter of polygon PQRS equals 85. Now, the key thing here that they want you to see is the perimeters are also proportional. So 85 divided by this perimeter, 68, is 1.25. Just like if I do 25 divided by 20, I get 1.25. So the sides are proportional, so are the perimeters. That's all I want you to understand there. All right, guys, I know this is a lot of notes. We will go over a lot of this tomorrow when I see you in person, but hope you have a wonderful Thursday.